Okay, 9.2, shaping planetary surfaces. So we're going to talk about how the other planets all have the shapes and the distinct qualities they have, okay? So we're going to be talking about the 5 terrestrial planets. Okay, all these things are shaped by 4 things, okay? You're going to need you need to know these 4 things. Number 1, impacts, asteroids, okay? Number 2, volcanism, that means volcanoes. Number 3, tectonics, that's the plate tectonics that move around. We just spoke about them in 9.1. And number 4, erosion, that's like wind, water, ice, things like that, okay? So these are the 4 things that shape the surface of all our terrestrial planets. So the first one, impact craters, okay? Most impact craters occurred in the beginning of our solar system in what was called heavy bombardment, which it was after all the planets kind of come together. Accretion kind of already occurred, but you still had a lot of asteroids flying around and stuff. That's where most of this happened, in the heavy bombardment area. Okay, now, one thing you're going to need to know is when an asteroid hits, the crater is usually about 10 times wider or larger than the object that made that. Okay, and it's based off of how much energy it had, how fast it was moving. And what's kind of nice about this is a lot of these things are moving kind of similar speeds. And so when they run into the planet, they're creating impacts, craters that are about 10 times as large as the asteroid itself, okay? Number 2, volcanism. Now this is when magma, or the stuff in the mantle, pushes its way through the crust, or the lithosphere, pushes its way through the lithosphere, and it gets its way onto the surface somehow. Okay, we have 3 types of volcanoes. You don't need to know those for now, though. But the different, like how dense or how viscous the lava is, will create different types of volcanoes. And once the magma gets out onto the surface of the crust, we call that lava. Yeah. Okay, on to the next thing. Number 3, plate tectonics. Okay, so tectonics occur because of the convection that's going on in the mantle. So convection's occurring here, and it's pushing the stuff that's the crust. Now remember, it's the lithosphere that it's moving. Okay, it's moving the upper part of the mantle and the crust together. Okay, so this convection moves the lithosphere depending on which way the convection is occurring. So the magma makes its way to the top because it's hot, and then it cools down, and then it comes back down, right? This convection, which is completely random in a bunch of different areas, depending on which way it's going. Notice these convection currents here that they've drawn are going in different directions. It'll move the lithosphere in different directions, okay? That's why you're going to have different, you're going to have a bunch of different plate tectonics that are moving in different directions, some running into each other, some moving away from each other, some kind of rubbing against each other. And we have names for all of these things, and we'll talk about them later in this PowerPoint, okay? On to the next thing. So here is where all the plate tectonics are broken up, as you can see on these yellow lines. Okay, so we have, I believe it's 13 plate tectonics, if I'm not wrong. I might have that. Maybe I'm thinking about something else, but somewhere like that. And these things shape our planet. They shape the planet the most, okay? And we've noticed how they are created, kind of like because we put puzzle pieces together. And so all of this started, I'm sure you guys have heard of it, Pangea, which is when all the continents were all one together, and it was just one land mass. And over time, these plate tectonics push them away. These things move at about a few centimeters, depending on the convection that's occurring underneath it and everything. They move a few to several centimeters every year. Okay, so your like, let's say North America could be moving at about 10, I think it's like something where like 10 centimeters per year for North America. Okay, so we are actually moving on the magma, right? We're not stationary like we think we are. We're moving. Okay, the last one, erosion. Okay, erosion is just a blanket term. I like what they say there, a blanket term for weather. Okay, now weather comes from different things. You got wind, you got rivers, you got ice, you got a bunch of different things that could erode, okay? So And we'll talk more about how this weather occurs in, I believe it's 9.3. Okay, so how do impact craters reveal a surface geological age? Okay, so the impact craters, how do they reveal it? So, like, basically, look at these pictures right here. If I told you to tell me which one has been dead the longest, remember, dead means that it doesn't have a solid center. I have a feeling you guys might be able to take some random guesses based off of the craters and the things that are on the surface of these planets, okay? So, most craters happen in the first billion years, and remember, I called that the heavy bombardment. That's when there's still a lot of asteroids flying around, but they've already accreted to create planets. A surface with many craters hasn't changed since then. So, like the moon. The moon has a lot of craters. Mercury has a lot of craters. That means they haven't changed much in 3 billion years. Because remember, heavy bombardment was about 1 billion years, and we're about 4.5 billion years old. So these two planets haven't really changed much in all that amount of time. Okay, so we will talk about how they have changed, though, in the next section. Okay, so if you look at the moon, there's like large dark areas. These are like flat plains, and if you go outside and look at the moon whenever it's out, I don't know if it's out tonight, but if you go out there and look at it, you can tell there's places with craters and there's places without. Okay, now the places without craters, we call those lunar maria, and these lunar maria, the reason why they have flat plains is because at some point there was lava flowing onto the surface of the moon. You got to remember, the moon was alive at one point, okay? So it had magma. That magma seeped its way onto the surface and created these lunar maria. And that happened in the first billion years because you can't see craters going on in there. So it was going around for at least 1 billion years, yeah? Okay. So why do the terrestrial planets have such different geological histories? Why the surface looks so different? Okay, remember, the number one thing, okay, there's a couple things, but the number one thing is the size of the planet. The larger the planet, the longer it will live because its surface area is smaller compared to its volume. So it cools down slower. The smaller the planet is, it's going to die quicker, okay? So its size is very important, because that will keep the inside of it warm, and that will allow for volcanoes and plate tectonics, which are all things that shape the surface. So a small world won't be able to do this. Also, a larger world has an atmosphere because we have the gravity to hold on to all of that stuff that's all that air and oxygen and carbon dioxide and things that our air is made up of. And a smaller world doesn't have that ability. Like Mars has a very thin atmosphere for multiple reasons, but one of them being that it's not large enough to really hold on to a real strong, thick atmosphere, okay? The second most important thing that shapes these planets is the size, and it's how close they are to the sun, okay? So the distance to the sun is very important. If you're too close, you're not going to be able to have liquid water, right? Mercury can't have liquid water. It's way too close. It's like 200 and something degrees over there. No, I think it's worse than that. On the remember, Mercury has a hot side and a cold side. Okay, so you can read through those, but they're pretty much what I was talking about. Okay, next thing is how fast they spin. Okay, this isn't as important as the other two, but how fast they spin has a very important part in how their surface is going to look. The faster you spin, the more weather you'll have. Okay, because think about this: so what causes wind and things like that on Earth? So we have an atmosphere. If the atmosphere rotates at the same speed as the planet, then you don't have wind. Okay, wind occurs when the planet and the atmosphere are moving different, aren't moving together. Okay, so if you have a faster rotation, that's going to happen less often, causing more weather. Okay, and also the faster rotation will create a larger magnetic field. Remember, we said that the rotation of those metals in the core creates a magnetic field. So you spin them faster, it has a bigger magnetic field. And those magnetic fields can save us from cosmic winds sweeping our atmosphere away, and X-rays and gamma rays getting to the surface of our planet, which we don't want because that would wipe out life on Earth. So these are all important things. Okay, so how does the cooling of a planet and potatoes vary with size? Okay, A, large size makes it harder for heat from the inside to escape. Large size means a bigger ratio of volume to surface area. A large size takes longer to cool, or all of the above. Okay? So, I believe that was the last one for 9.2. Okay, we're done. I hope you enjoyed.